Well, hey everybody. My name is Vlad Razanovich. I run the AMD organization for cloud sales at AMD, and so it's going to be an intimate crowd. So we'll spend a couple minutes talking a little bit about kind of the things AMD is doing in the market. We'll leave it open for questions at the end, right? I mean, especially if it's going to be a small crowd today. But a couple things that I wanted to point out. I'm going to have a couple guests join me up on stage as well. And so in addition to getting a rundown on the AMD side of things, where we're going with EPYC and some of the offerings that we have, we're also going to have the co-founder and president of Densify, a cloud optimization organization that's really helped a lot of organizations out there, Riaz Somani. He's going to come up and share a little bit about what they're doing with end customers, specifically in the market for optimization and making sure people are really right-sized to their environments. And then we're also going to have a customer come up who actually has seen some of those advantages around AMD cost savings, and that is a company by the name of Ample Organics, based out of Canada, who is actually in one of the hottest industries today. And so I know this video is going to be filmed as well, so we're hoping that there's going to be more folks that join over time to take a look at what we're going to talk about today. One thing I will say is that we are giving away some awesome Radeon graphics cards today. So if for those of you who are here, you've got a good chance at taking home one of the new Radeon 5700, and it's from XFX. So I'll do that raffle here at the end. One thing I was going to point out is if you have your cell phones ready, we are going to do a couple text polling questions. All you have to do is text AMD 646 to 22333. Or if you go up to a browser, if you go to pollev.com/AMD646, we'll do a couple of polling questions just to kind of keep you guys interested. And if you don't want to do that and raise your hands, we can do that as well. So so like I said, one of the things that I was going to spend some time talking about today is where is the market going from a cloud standpoint, especially when we look at the areas of processor technology. As everybody probably understands at this point, AMD is back in the server market. And we've introduced our EPYC portfolio of products, which is really an exciting thing for the marketplace. And I'll spend a little bit of time talking about what we are doing to go drive new product enhancements that's really going to attack the cloud market and drive products that are really going to be ideal for obviously EC2 and offerings that EC2 is going to put out there in the market. It's nothing new, right? The market is absolutely growing at this point in time. If we look at back just 45 years ago, how much spend was actually going to cloud or hybrid environments. What you see now is that when you start looking at predictions, whether it's from IDC, Gartner, or other corporations out there, they're all talking about how over 65% of the market is going to be moving into the cloud space. And again, it's not a surprise. It's one of the reasons we're all here at reInvent, is to really kind of do a deep dive on where is the market heading. This is not a phenomenon that's just that's going to go away. And this is one of the reasons that AMD is building processors and building graphics cards that's really tied to and geared for the cloud market. The other thing we see is that people are spending a lot more money there too, right? And this is really going to be kind of the highlight of my talk, is that when you start talking about the amount of money that people are spending in the cloud market, I'll tell you, I've just recently met with the president of one of the largest CRM software companies out there, and he was telling me that his spend with the cloud providers is going to go up about 3x this year over last year. And so it's even more important that you as IT decision makers really start taking a look at what are the things that we need to do to optimize for costs, to optimize for your usage models, and to make sure that you're getting the most for your money, especially when you start migrating to these cloud environments. And so, okay, I'm going to do my first polling question here. Is anybody aware of any of the EC2 options that are powered by AMD EPYC processors today? Let's see if this works. If you guys go back to that text that I showed at the beginning of the screen, we'll see if this works, and if it doesn't. Well, no, okay. I didn't see anything pop up there. So you know what? We'll. I'm not sure if there's a connection that's not working here, but you know, one of the things that I'll talk a little bit about today is what are those AMD options within the EC2 environment. And so, you know, real simple way to look at it. Anything that ends in an A is going to be an AMD-based instance within the EC2 environment. So the newly announced C5A, M5A, R5A, T3A. And so, you know, I'll spend a little bit more time later on talking about those specific instance types. But what I wanted to do just for a little bit here is talk to you about kind of some of the breakthrough stuff that AMD is actually doing. So back in the August timeframe of this year, we introduced something called our EPYC Generation 2 processor, which is our codename Rome-based CPU. You know, this is something that's kind of groundbreaking in the industry, right? You know, AMD went to a process technology, which is a 7 nanometer process technology, where our competitor is still about one and a half generations behind. You know, the whole idea here is that the smaller you can make your geometries, the more power you're going to save, the more transistors you can put on a piece of silicon. And that's really what AMD did. AMD also looked at this saying, how do we modify the architecture within one of these processor designs? And we call it a chiplet architecture, because we don't try to put everything on one monolithic piece of silicon. You know, the only thing that you can do with a monolithic piece of silicon is, you know, it's going to add a lot of power to the equation. It's going to add a lot of failure potential to that equation, especially in the manufacturing process. So we did something called a chiplet design, where we put on our 64 core product, we have 8 different chiplets talking to an IOD, which then is actually communicating to the outside world. What that does is it allows us to scale the amount of cores within a piece of silicon, and it also allows us to do things like, you know, for some of that I/O and memory interfaces, you don't have to transition to the newest processor technology or the process technology as fast as you need to. So what this has done is this has allowed us to create a processor architecture that's 64 cores in a single socket, 128 lanes of PCIe coming off of each socket, 8 memory channels coming off of those sockets, and also supporting up to 4 terabytes of memory. So if you think about it, you know, for anybody who was potentially out at supercomputing in Denver 2 weeks ago, AMD made a huge splash at supercomputing, because, you know, basically anybody who is utilizing cores, utilizing floating point capability, utilizing memory bandwidth and I/O bandwidth, they have all announced that they're going to start moving towards the AMD EPYC Generation 2 architecture. So much so that we even announced some of the largest potential supercomputers in the world. The Frontier system, which is coming out from Oak Ridge National Labs in the 2022 timeframe, 2021, 2022 timeframe, that's going to be a 1.5 exascale type system. And the way they can build that is through the use of our technology, both on a CPU and a GPU level. And so if you think about where we are today, right, we're at this, what we call the second generation of our Zen architecture, which was just introduced this past October. EC2 has had AMD technology in the M, R, and T instance types using our first generation technology, and that's not going away anytime soon. We have numerous customers that have jumped on board to those M, R, and T instance types. In fact, even earlier today, Expedia went up on stage at one of the breakout sessions to talk about why they transitioned over to AMD within the EC2 portfolio and some of the cost benefits that they've seen. And we'll talk a little bit more. Like I said, I've got the guys from Ample Organics here today, and they're going to show you a little bit of the cost savings that they have seen as well. So AMD's not standing still. You know, one of the things we're looking at what is the next generation that we need to prepare for. You know, we're ahead of our competitor today. How do we make sure we stay ahead of our competitor for the next 2 generations? And so we're already in that phase today. So next year we are introducing something called our Milan product, and that's based off of our Zen 3 architecture. So if we want to dive down into kind of the technology there, what we're doing is we're staying in that same 7 nanometer process technology, but we're doing a whole new core architecture design. And so today, and I'll show you some benchmarks on kind of how we look from both the data analytics standpoint, maybe a database standpoint, but one of the things that we do is today we are approaching performance via a brute force method. More cores, more I/O, more memory, and that's how we're beating the competition. When we introduced our Zen 3 product, one of the things that we have said to the marketplace is we are going to beat our competitor on a single-threaded single-threaded performance standpoint as well. Not just by a brute force method with more cores and more I/O and more memory, but we're actually going to beat them even at the single-threaded performance level. And it's really what we kind of call our clean sweep of performance from a win standpoint. And we're not going to stop there. You know, the next product we're already working on is a product called Genoa, which is going to be introduced in that 2000. I'm not sure I can say the time frame yet, but it will be introduced shortly after the Milan product offering. So if you think about the cadence that we're hitting right now, we're looking at a new CPU introduction once every 12 to 18 months. And so you should see that path going forward as well. And we're not going to stop there, right? This is an area where we're going to continue investing in the server technology roadmap that we have. And so where are we today with Amazon? With AWS, as I mentioned, you have a good portfolio of products within the AWS environment. You have the M, R, and T instance types, as well as what's called our AppStream 2.0 environment from a GPU standpoint. So currently, if you are running anything that's on AppStream 2.0, you are actually running on AMD Radeon GPUs, Radeon Pro GPUs. It's something that's not promoted out there, but it's something that you should know is the back end to those AppStream servers. And one of the things we're most excited about is AMD introduced, or excuse me, EC2 just introduced what's called their C5A Instance Type. And so this is something that EC2 spoke a little bit about this morning, where within the product portfolio, you now have a compute instance type, which is taking advantage of our new 7-nanometer Rome processors. And so the specs of this are currently being made available from AWS. But when you look at what are the target markets that this is going to go after, this is really going to start going after, you know, anything that's going to take advantage of more core count, more memory, more I/O, right? So whether it's container environments, virtualization environments, VMware type environments, whether it's data analytic environments, or whether it's high performance computing environments, this is where they're going to really target C5A. And so from what we have seen on benchmarks that we have done internally at AMD for going after this market, I think EC2 is really kind of nailing the product positioning of this. And so the positioning that they're going to have is, if you look at compute optimized, right, this is where the majority of those C5A deployments are going to go into. And so that's where C5A, and by the way, it's also C5AD, C5AN, and C5A bare metal. So for the first time, EC2 is going to be offering bare metal instances using AMD EPYC in their products as well. And so really, when you start looking at all the core platforms that are out there, now you start seeing general purpose in the M instances and the burstable T instance types. You also see the memory optimized instances in the R5A, and now it's rounding it out with the C5A products. So if we start looking at the specs of some of those offerings, this is where you start seeing, you know, how is AWS actually positioning the AMD instance types? So the way they're positioning this is about 10% cost savings over comparable C5, M5, T3, or C5 instances. And so this is where you'll see the workload positionings that they're going after. You know, in your typical general purpose M5A, M5AD, this is where you really have the test and dev environment. This is where we've seen the most traction with the M5As and the M5ADs, is anywhere where you have a test dev environment, you know, enterprise application. That's really the ideal instance type for those types of offerings. When you start looking at the memory optimized, this is where the big data, the data analytics type rollouts start really becoming a use case, usage model. And so that's going to be the R5A, R5AD. The T3A, this is where you're going to get your burstable instance types, right? Spot type instances, aggressive type pricing. And this all, again, these are all based off of the Zen first generation or EPYC first generation products. So M5A, R5A, T3A, all based off of that first generation EPYC product offering. And this is, you know, where have we seen the majority of deployments for this? This is going to be in your microservices. And so this is where you can get instance sizes down to the nano instance type. So the really small instance sizes within the EC2 environment. If you've noticed, all of those products I just talked about were all based off of what we called our Naples offering. So first generation 2.5 gigahertz. We do a custom silicon for AWS. So even though it is a 32 core Naples for those offerings, we do a higher frequency, a higher power level so that they can actually deliver more performance. The AWS data centers, they're obviously state of the art, and we do something that's very custom for Amazon in those areas. And so this is the one that's really exciting for us from an AMD standpoint. The C5A, C5AD, as well as the bare metal instance. This is where, again, AWS is doing a custom Rome product with a base frequency of 3.3 gigahertz. And so you'll notice that's a little bit higher than, actually a fair bit higher than what you'll see from our general available products in that processor core count range. And so this is where we start seeing the performance benefits for, like I said earlier, high performance computing, scalable workloads, things that you start looking at video editing, batch processing. This is the area where you're going to have a lot of use cases for those types of instance types. And when you think about how AWS is going to market these, it's very simple. It's all about lower prices, processor choice, and application compatibility. We have had dozens and dozens of customers come back to us by using the Nitro system that EC2 offers, where people will literally spin down maybe an older generation M4 or an R4 type instance or even an R5 instance, migrate that data, spin up a new R5A or M5A, and they will see 10% cost savings. In many cases, if your performance isn't highly single-threaded, you're not going to see any performance degradation whatsoever. And this is where we have seen the majority of customers really show a benefit to migrating over to AMD. And it's all done via that Nitro stack that AWS offers that allows you to migrate from one generation to another. As far as being available globally, this is an area where we have had a lot of success. Over 18 geographic regions right now are carrying the AMD EPYC instance types. 57 of the 69 total availability zones. So if you have a zone that does not, that you as a end user may not, where AMD is not available, please let us know, or please let your AWS salesperson know, and that will definitely make sure to bring some of those availability zones into other geographies. One of the things that's really interesting, I'll kind of pop up here, is about 10 days ago, AWS announced that they just launched in the Mumbai region for the M, R, and T instance types. And what's really cool here is that they put it out at a pretty ridiculous aggressive price at 45% cost savings to a comparable offering, right? And this is an area where I think you can see that Microsoft has made a lot of traction into the India market. And so AWS is being very, very bold here, and by looking at the performance and the pricing that AMD offers, they allow you to get to a point where they can do some real bold statements to the market, like 45% cost savings for same type of SLA, same type of instance type. And so that's something that we're trying to have AWS bring to even more regions to deliver even more customer value. So I don't think this was working before, but if like I said, if you don't have a product that's in the region, please let me know, or please let one of the AMD sales teams or even your AWS sales team know. The other thing we've seen is super ecosystem support for AMD EPYC out there, whether it's Microsoft, Citrix, VMware, whether it's your container services, Docker, hyper-converged environments like Nutanix. These are all areas where we have seen a tremendous amount of ecosystem support. And based off of that high core count that I mentioned earlier, I'll show a couple benchmark slides here that kind of shows what the scalability is from a core count standpoint on AMD EPYC on some of the M5 instances. So especially when you're starting to add Dockers, containers, this is an area where you have a lot of core count matters, right? And so if you start looking at EKS or ECS types environments, this is an area where higher core counts matter. And so when you look at your M5s, you look at your R5s, you look at your C5As, this is an area where we will have near linear scaling from a performance standpoint. The other thing that we look at all the time is cost savings, especially in areas like test and dev. if you are operating in an environment where you don't need that best performance and uptime and SLA is the most important thing, this is where we have seen the majority of customers actually take advantage of going to an EPYC-based system. And as you see up on the screen here, this is an area where over $235,000 was saved by a particular end user by switching over to an AMD EPYC instance. Database scalability, again, core count, I/O, memory. Right? You're going to see this theme here from AMD, core count, I/O, memory. Any area where you see this advantage, this is where you're going to have, again, near linear scaling for things like online transaction processing and also in your analytics environment across decision support. So these are all areas where we start seeing this linear scaling going, from a core count standpoint across all of the instance types that AWS offers with AMD EPYC. So at this point, I'm going to take a breath, and I'm going to introduce one of our good friends from Densify. Riaz, who is the president and co-founder, who I mentioned earlier, is going to take us through a little bit about what is that advantage by doing kind of an optimization from a resource standpoint. So Riaz, I'll hand it over to you.
Thank you.
You got it.
Yep. Thanks, everybody. Appreciate the time today. I know that I'm standing between you guys in a draw at the end and swag on the vendor floor. So I'm going to keep it as tight as possible. All right, so first of all, thanks, Vlad, for inviting us. So we provide an agnostic platform that analyzes workload patterns. I'll get into it. And so there's no fudge factor in what we do. One of the reasons that we've decided to partner with AMD is that we firsthand have seen the impact within our customers. If as they've migrated workloads to the AMD chipset, they've achieved higher performance at a lower cost, and we're seeing a significant move to the chipset. So we've enjoyed a very good partnership with these guys, and we try to showcase their capability as much as possible. Just naturally, empirically happens from our analytics. So what is it that we do? We describe ourselves as hybrid cloud and container resource optimization. At the heart of our solution, we provide a software platform. It's machine learning analytics, predictive analytics, 11 patents under the covers, that's focused on understanding application workload patterns. What is the demand pattern, the imprint that they make on the supply side, so that you can understand what is the optimal supply to match with the application demand. The goal that we have when we do so is to drive the highest level of application performance and elasticity, but also deliver it at the lowest cost possible. We're very application-centric, which is different than a lot of the cloud vendors out there that are focused on cost management. We believe that if you're going to look at resource optimization, you have to look at the application, the utilization patterns, before you choose to make any changes. And then you have to augment it with capabilities for the finance team so that they can apply financial coupons that sit on top of your resource consumption to further optimize from a savings perspective. It's very different than the other approaches in the market. We've graduated through the years in terms of how the ecosystem has changed, and I've got a lot of gray hair to show it. So I was around in the days when we actually had physical systems. So when you think about resource optimization, the complexity goes up as the maturity of our environments start to change, but also the impact is much, much higher. So as an example, back in the physical world, I did it. I built derivatives trading systems, transaction processing engines. I went and picked a server for my application. I made the choice, stayed the same for the next 3 years. Hopefully I got it right. I probably doubled, tripled what I needed just to make sure that I have enough headroom. So now you move up this stack and you go to virtual, it gets a little bit more complicated. So now you've got a multi-hierarchy relationship where you've got VMs sitting on hosts that are part of a cluster, and the challenge becomes a little bit more complicated. You've got noisy neighbors, you've got context switching to worry about, and in general, the hierarchy becomes highly interrelated, so optimization becomes ever more important, and the impact is very, very significant from a performance perspective and financially. Now you move further up the stack and you get to cloud, and you say, well, isn't that easier? Theoretically, it is, because from an end user perspective, so from an end user perspective, you're thinking, I'm single tenant again. I don't have to worry about multi-tenancy. That's true, but according to Gartner last year, there are over 1.7 million combinations and permutations of supply that you can subscribe to. How do you know what the right supply is for your application workload that you've written in microservices, and it's all 14, 18, 30, 40, 50 different components. It becomes more challenging. And statistically, what we found within our customer base when we bring on a new customer, 51% of the supply that they're subscribing to is not the best suited for their application workloads. Over 50%. And I'll get into some of those details, some examples for you. Then you get into the container world. Now the hierarchy becomes even more complicated. The interdependencies become higher because you're subscribing to containers in terms of their resource requests, in terms of shares and limits, and then you're sitting inside pods that are scaling in replica sets, that are sitting on nodes that are part of a scale group. You think about how critical it is and how the impact changes based on changes that you make at every level. And what we find repeatedly in these types of environments that are running EKS, AKS, ECS, OpenShift, bare metal, on-prem, is that there's this huge disconnect where there are performance issues, but there's massive over-allocation of resources. So we're very, very focused in the high-growth area in containers to help optimize these for our customers. When we talk about optimizing hybrid cloud resources, we like to take a three-step approach. One is about purely observability. Understanding your application workload patterns. For those that are stateful, they typically have a pattern. So if it's a batch job, they get busy at a certain time, they have sustained activity, they have a certain peak activity, they might, over a 95-day period, just peak during certain periods. Understanding that is very critical. For stateless and highly transient, you look at the composite workload in terms of the group and the impact it has maybe on a scale group factor. So understanding the mins and the max become more critical. There are a lot of tools out there that are focused on monitoring. The Grafana's, the Prometheuses of the world, SignalFX, Datadog, great products that we ingest information from. Our goal is to understand the pattern and the resource impact that they have so that we can then optimize it. Stage 2 for us is the optimization. It is selecting the best resource type for your application workload and then integrating it from a process perspective, I'm going to talk about it, into your ecosystem so that you can actually take the recommendation. I'm going to talk about developers and what their profiles are, and candidly, for the right reasons, the way they put their pants on in the morning and what they're focused on. Okay? And then the last one is procurement optimization. I separate this because I think it's important to not have the tail wag the dog. And what I mean by that is there's always opportunities to save money. But first and foremost, it's about the application. You have to make sure that your application maintains performance and improves performance potentially as you're making a change from a resource perspective. And then layer on the financial instruments that the cloud providers provide you, like Amazon, with reserved instances, with savings plans, and maybe even the type of purchase in terms of on-demand or spot is another procurement strategy as well. So it's a three-layer approach that we like to take. And what's interesting in terms of dynamics, in terms of what is optimal, I'll summarize for you. Just again, I've lived it myself as an app owner. Probably as a young app owner, had a few too many chips on my shoulder in terms of what I did, right? But at the end of the day, I know that I get rewarded and I don't get fired if my performance is the highest, my reliability is the highest, and if I am delivering for my end users, right? For that line of business, it's a retail trading app that I did. What's critical is end user performance. So when I think about performance and cost, I care about improving performance and maintaining my cost because my boss's boss cares about the budget and I want to do the right thing, but first and foremost, I care about performance. Now, you flip over to the finance team, right? Rightfully so. They are gold and understanding for the same level of performance and output that we can put out there, can we reduce our costs, right? So now you've got this dichotomy in terms of what's driving behavior, but it's critical to view these requirements and separate the strategies for both of them, okay? So what we like to do is break it down in further detail in terms of very specific recommendations based on the machine learning. I'm going to get into what's behind it, but a number of recommendations that we make can improve performance and stability, but they can also improve from a cost perspective. So instance resource optimization. So we're talking about basic like EC2 optimization. So the ability to upsize, modernize, move cross-family, reclaim, and terminate. That cross-family, I'm going to talk a little bit more about that because that's the sweet spot of what we're seeing in the challenge out there is that most workloads, over 50%, are running in the wrong type of family. Vlad showed you earlier, right, there are basic categorizations. If it's a web app, I can run it in general purpose. If it is a high-performance database, I want to put it in memory optimized. So there are general patterns that you follow, but the reality is as these applications go live, right, their primary, secondary, tertiary limits in terms of saturation from a resource perspective change dramatically over time. So understanding that pattern and therefore what the right type of supply becomes ever more critical. It gets far more complicated when you're talking about a scale group. And being able to understand what the node size is, what the node, in terms of whether you can modernize it, whether you can go cross-family, and you're scaling min and max, right, becomes a harder challenge to optimize. We're highly focused as a company, but I will tell you, it's ever more critical. If I'm an app owner from a performance perspective, one of the things that I hate the most is warm-up time, right? If I can avoid the concept of delayed elasticity, if I can proactively manage my resources and scaling factors, if I can get the right min and max so that I can drive that so that I have perfect end user performance, that's what I love, okay? And the last one is with respect to containers that sit on top of all of this, right, in terms of requests and limits and initial values. So we're seeing, because of that selection process happens up in the stream where developers aren't necessarily impacted, right, they will put a high request, high limit, right, and now it gums up the scheduler from the Kubernetes perspective, and the impact is felt across all of your platform and every other app owner as well. So it's critical to nail this. Now, when you do this, it actually benefits both parties. But our target when providing the recommendation is the engineering and the app owners, and naturally finance likes it because what we find is over time, and I'll walk you through the process to how we get people to start to take the recommendations, is the app owners start to take the performance-oriented recommendations, and then just naturally they start to get into the rhythm and do some cost savings, and it just improves and improves. And then also through modernization, like moving to the AMD architecture, you get bang for the buck and lower cost. So it's fantastic, okay? So behind the scenes, people say, okay, that's great, interesting. You say that you provide these recommendations. What exactly is behind it that I can actually trust them? So we pride ourselves on this. Deep machine learning, predictive analytics. We look at the application workload patterns. So we're looking at the busiest day, the typical day, over a period of time. Most of our customers run 95 days. Some run 13 months of data. We've got the large retailers and customers like that. That really care about business patterns. They have a lot of stateful legacy workloads in addition to transient workloads. So we're looking at CPU, memory, disk, and network. And then what we're doing is we're understanding the supply side of the equation. So from a cost, we have it fully categorized across all of on-prem, including public clouds, all AWS, Azure, Google, and even SoftLayer. So we can do an apples to oranges comparison. And what's important as part of that is we use a benchmark, the CN 2017, that we augment as well so that we have a proper normalized benchmark. So when we're telling you to go from an R5 to an M5, we know, right, that actually, no, you know what, you should go from an R5, you can go to an M5A, and it's running the EPYC chip underneath, and you're going to get much better price performance for that move, okay? And then we're doing the technical checks, which is critical because if I make a recommendation to you, you got to know, is it easy to take or is it difficult? So we're looking at things like, is it EBS optimized? Does it have local storage? What's the AMI sitting on, right? Is it network optimized? What's the paravirtualization that I'm running? To determine, I'll call it the effort factor if I need to move this, right? Can it just be automated, or am I going to have to roll up my sleeves to make this move, okay? We infuse it with what we call business constraints, and the equivalent of tags, but we leverage this information so that we can do contextual analysis to say, hey, I'm going to analyze these things. They're part of a fault-tolerant pair, so analyze them together and make sure you land them separately so that it actually has business context. We layer on fit-for-purpose policy. So an application that's running in dev test for an internal IT, right, app is very different than a production critical user facing, so don't give me the same answer. You know, I can look at 7 days of information for one, I want a full cycle on another, I don't want to just look at sustained, I want to look at peak activity, never go over 60%, right? So that type of contextual analysis is what we enable. We take this information and we output cloud resource optimization recommendations, like I described earlier, moving to an M5 AD as an example. And our analogy is Tetris, so that we're fitting the workload to the right shape, right, of its pattern. We then also apply the same analytics for multi-tenancy to understand what cohabitate well together, and therefore how much headroom can I leave, right, for future activity as well. And then we do migration analysis, not just within AWS, but very common. I'm moving my legacy VMware environment into AWS, right? And I need to know exactly how to size it, where to land it, and if I actually decide to containerize at the same time, what's the impact, right? What kind of limits should I set, and what's the underlying node architecture I'll need underneath EKS and the scale groups, right? So all of that analytics comes with the product, and then we layer on the financial optimization. What we're very focused on, just based on personal experience that we've all had as part of the engineering team, is that it has to integrate into the ecosystem. So I'm going to go into some of these details, but from a report perspective, but also from an ITSM change management perspective, right? I can't just take a recommendation, fly it over, and implement it without the right people approving it. It has to integrate into and I'm going to talk a little bit more about this in terms of how people work. I always say that my engineers, they have 3 things open at any given time, right? They have an integrated development environment, right? Slack and Google's open because they couldn't find something in the first 2, right? So we have to cater to that type of workflow so that we integrate into the process. And then last but not least is just the automation frameworks have drastically changed today. Infrastructure as code, declarative language is where these decisions have to happen, and so we have to infuse our answers into those ecosystems. So if I dig in a little bit, I'm going to go a little bit fast here in terms of the hybrid journey. We've got customers, you know, all across the board in terms of where they are. In this case, financial institution, very large, on-prem, you know, 80% on-prem, aggressively starting to move to the cloud, a little bit late because of regulatory. The one in the middle is a tech, it's a software company, highly automated, infrastructure as code, right? Very big on ASGs and taking our recommendations to optimize in terms of the scale groups. And then the last one's a retail one that I describe as 50% on-prem, 50% in the cloud, but what they did was they skipped a step. They said, screw EC2, I'm going straight to they're running in different clouds, but Kubernetes flavors, right? So we're seeing that more and more. So now let's talk specifically about AMD. And again, I'll come back to how I started in that this was a partnership that developed based on us having empirical evidence in field. So here's a customer example where we've got 1,600 instances, and the first thing that I'm going to point out is that only 49% are just right in terms of the supply side, right, relative to their application workloads. 51%, right, are lacking. That could be in a better state. They can actually be change families, right, for more optimal performance and cost, or they can be modernized. So to the right here are the examples. The analysis naturally spits out the best, right, supply for that application workload, and you'll see pretty much all of these guys were moving to AMD's latest EPYC chipset. So this is what we were seeing in field. The estimated cost in terms of where the financial benefit is shown on the left-hand side, but more importantly on the right-hand side is the estimated effort. These are related to the technical checks I was talking about earlier. And what we mean here is, okay, when we say no effort, I can actually automate that change. Okay, on the next code release, boom, I can move it, right, to an AMD instance and not have to worry about it. And then some are moderate, some are low, and some are very low. When we talk about moderate, you might have to recycle the AMI as an example. So we're saying, you know, schedule it and you know, do it appropriately. Maybe it's not immediate. You're going to evaluate it with the dev team. Okay. So digging in, when we're providing our recommendations, And so in this example, we're going from an R to an M, I believe, if I can read that right. So, oh no, we're going from an M to an R. Okay, that's good. So M to an RA. And so in this case, we know that we're going to be better off from a memory perspective, right? But the example that I'm showing here is I'm looking at the CPU, and I'm looking at, in terms of the predicted day, in terms of the outer envelope of the pattern, and then the busiest day in terms of before and after. The blue is before, the green is after. To say, hey, I'm moving to memory optimized. What's it going to look like? Worst case scenario, looks like I've got more than enough headroom. So it's a predictive analysis to say you're going to be okay, okay? And so what's important, right, when you embark on the strategy of resource optimization is to understand from a developer's perspective. I always like to look at it this way, and that is, I as a developer don't like three things. One is other people screwing with my application, right? Two, changing anything. And three is doing anything other than development, okay? So when you think of it that way, right, we've been very focused as a company to say, okay, if we're going to go to the app owner, the app developer, right, for this change, first thing we got to do is tell them you're going to be okay, that we got you. So we produce a very specific application owner report that says, this is the change that we're proposing, right, based on the machine learning, based on all of the policy details. We looked at 95 days. We looked at sustained activity. We looked at your busiest day. We looked at the business cycle. We looked at everything. And the net of it is you can and should move to this new AMD chipset, right? And by the way, you're going to save a whole bunch of money. But more importantly, in this case, this example, this is a modernization where your actual resource usage is going to be better off. So it's the 1-2 punch. You're going to save money, right? And you're going to get better resource usage, right? More headroom. And the beauty of this is, then the question is, okay, how do you make it easy? Because I want to just develop. I got it. I don't disagree with this. So how do you make it easy? You make it easy by integrating it into the process. We coined the phrase about a year and a half ago, and a lot of people have picked it up, which is a great thing for us. And that is layering on, in terms of continuous integration, continuous deployment, the concept of continuous optimization. So how do you integrate this recommendation engine into the process to make it easy for developers? We actually are constantly analyzing these resources and the applications that sit on them and integrate at multiple stages, either through change management or into the pipeline, either at version control, at the integration phase, or actually at the provisioning phase. And I'll give you some examples of what I'm talking about. The whole idea is to make it easy for the developer. Here's an example of a Fortune 100 customer. It's an insurance company. And this is their ecosystem in terms of their dev pipeline. So we analyze and we collect the data and we write our recommendations that are consistent with their high-level financial reporting that they're getting in terms of opportunity to say, in an AWS DynamoDB, here's the recommendation from Densify. The application owner is presented, I think it's in CloudForge, and they can actually decide to take the recommendation when they look at their dashboards. And then on the next build and deployment, it automatically picks up the new Densify recommendation, puts it into CloudFormations, and updates the stack automatically. So it's integrated in the declarative language, the reference point, and it's just seamless. So with this company, what we did was they were one of the first ones to move aggressively to AMD. And then from there, what we did was they were manually taking the recommendations based on the app owner reports, and now we're starting to integrate it across their lines of business so that it's fully automated. The other thing that they are doing with us, which we came up with last year, was this concept of optimization as code in the declarative language for all new applications, right? It's been stated that, look, guys, let developers develop, right? Let machine learning actually optimize in the background. So the idea of micro-purchasing and making a selection, it's like a kid in a candy store. I take my 8-year-old in. Worst thing I can do is give them selection, right? They're like, take 20, 30 minutes. So what I do is say, get what you got last time. Boom, he's out of there, right? He's happy, right? But that's what everybody else is doing out there. So how do you avoid it is you integrate it right into the declarative language, you remove the micro-purchasing, and you let developers develop. You give them the option to reference machine learning. This is a simplification. There's obviously a default type that we deploy with, and then over time, as we hit our policy, we go to optimize, right? And it goes from hard coding to self-optimizing. That's the way we like to describe it. And the last one that we like to do from an app owner perspective is enable full upstream self-service. And what we mean by this is let application owners decide what they care about. And through Slack, what we've done is we've enabled full self-service to say, as an app owner, I care about my mobile service. I don't care about anything else. Now, when you give me recommendations for my mobile service, don't give me terminates, right? I know it hasn't spun up in certain areas. I don't care. I don't care about CPU going over 60%, right? I care about downsizing, but not so much right now. I love the idea of modernizing. And you know what? I'll automate anything that's going to improve my scaling. So full self-service to describe, get the app owner directly in Slack so I can look at it, like it, and decide to, if I want, approve the change right through Slack. And it's integrated downstream into that CI/CD/CO workflow. Okay? Now, what ends up happening is finance says, that's great, but I have needs too. Which is completely appropriate because here's where you can really save money on top of doing everything we talked about from a resource optimization perspective. From a finance perspective, there's so many opportunities to leverage, right, coupons, to leverage the ability to buy at a payer account. But in order to do that, you need cross-charging capabilities. You need to have things like anomaly detection. You need to have things like RI portfolio management so that you understand what to buy, what to convert, right? And also what to purchase on the anniversary based on your resource consumption. Utilization, coverage, all of that's critical. People ask about savings plans, and does that change things? It absolutely does. But it's interesting, we are even finding today that a lot of large companies are still very fixated, rightfully so, on guaranteeing capacity by buying AZ scope reserved instances, right? So they're still buying new ones as opposed to savings plans. And then last but not least is the savings plans. So that was just announced. We provide that capability as well. So our whole goal is this end-to-end platform that's focused on the application. I care about the cloud platform owner, the engineer, the app owner, the container platform owner, and then separating but providing value to the finance owner as well. So that it's a very cohesive platform that you can leverage to optimize your resource selection. People ask us, it's great, it's machine learning. Sounds interesting, is it difficult to use? It's actually pretty straightforward. 15 minutes to connect. All we need is AWS credentials. If you're analyzing an on-prem VMware environment for a move to the public cloud or optimizing on-prem, it's 30 minutes because we deploy a connector. It's pretty straightforward. We pride ourselves on the fact that our whole approach is, instead of a rental car type approach, we provide rideshare or Uber or Lyft in that. Just tell us where you're going. We'll help you get there. So you don't have to figure things out on your own. And last but not least, we're very proud of the fact that our customers love our approach to solving your problems. And we've got an NPS, Net Promoter Score, of north of 50, which is considered to be great in the industry. So hopefully you found that interesting. And I'll tell you again, appreciate the opportunity with AMD. We're seeing quite an impact in field, just empirically speaking. So we're very excited about what we're doing with customers that, as we're moving them to AMD as well. And with that, I'll turn it back over to Vlad.
Awesome. Thanks, Riaz. I'll tell you, I love Densify. I love what these guys are doing. I love how you as IT decision makers can go back to your CFO or your IT finance organizations and say, here's how I'm going to save you money. I really think it's an amazing offering that they deliver to the marketplace, and it's one of the reasons that we've actually partnered up with them, because there's nothing better than actually to say, hey, you know what, I'm going to give you more performance for your money. I remember being over at the AWS Summit in Chicago, and one of the big cereal manufacturers in the Midwest came up to me and said, hey, you know what, I moved everything over from on-prem to the cloud into AWS. And a couple messages about, saving 10%, that makes a big difference for guys like this. Their spend is about $900,000 a month in the cloud. And what they told me, they said, you know what, by using tools like what Densify offers, it pays for itself. It literally pays for itself. Because what you do is you can show cost savings, you can add developers, you can, all at the same time while increasing performance and raising your increasing performance, lowering costs, all by utilizing the service that they provide. So thank you, Riaz. You know what? We're going to switch it up a little bit here before we get into the raffle at the end here for some of the AMD graphics cards. So one of the things I wanted to do is I wanted to actually introduce to you a organization out of Canada called Ample Organics. They're in one of the fastest growing industries in the world today. And so they are actually users of AWS and users of AMD. And so I wanted to introduce Glenn Yu and Frank L. From Ample Organics to tell us a little bit about what they're seeing with their migration over to AMD within the cloud. Great, thanks Frank.
Thank you,
Thanks,
Vlad.
Glenn.
Hi, folks. So who is Ample Organics? So we've been providing technological infrastructure for the cannabis industry since 2014. We've been quickly growing. And yes, it's cannabis. Sorry, no samples. But yeah, so we've been providing quickly growing for the cannabis industry. We've right now running on our platform about 70% of the Canadian market, and it is powered by AMD. So when the question came to me from Glenn was, hey Frank, what if I can lower our cost, increase our stability, and reduce our risk? Obviously, that's a no-brainer. Anyone would say yes to that. So we obviously went ahead and did that. And Glenn's here to talk a little bit more about the journey to the transformation of the migration.
Hello. So as Frank said, we at Ample Organics benefited a lot out of this partnership. From a performance perspective, ever since switching over to AMD, we've seen equal or better performance. So whether you're on the T3s, the M5s, R5s, or the soon C5s, there's an AMD equivalent for you. And this comes at a 10% savings cost, which is, I mean, we're just a small startup. We have about 650 EC2 instances of varying sizes and types across our dev, UAT, and prod environments. But 10% is 10%, and for us, 10% is huge. And migrating couldn't be easier. We use Terraform infrastructure as code to manage our infrastructure, so it's as simple as adding that letter A in your code. From a security perspective, in recent years, there's been a lot of, you've probably heard of Spectre and Meltdown and things like that vulnerabilities that seem to affect processors. And because of AMD's different architecture, they're relatively, they're less impacted by these. And if you've been following, tech news, I think about 3-4 weeks ago, Zombie Load Variant 2 came out, and that had a huge impact on Intel processors. But AMD was not affected, and when I see news like that, I can just breathe a sigh of relief because I know this switch, made it possible that made us safe. And from in our industry, a lot of our clients have patient info, so security and privacy is really important to us, and this is a real blessing. And this journey, this partnership, my favorite thing out of all this is how supportive and how responsive AMD has been. We're just a small startup, 5 years young, and they are a global company with 50 years of history, right? But when we talk and we communicate, we feel like one of the big boys. So thank you so much.
Thank you.
Yeah.
And that's pretty much our journey for the migration of Intel to AMD in our cloud.
Awesome.
Thank you, Vlad.
Thank you.
Well, Frank, thanks a lot. Glenn, really appreciate the support and the opportunity to talk a little bit about what you're doing. So, and congratulations to you guys. I mean, you're in an amazingly fast-growing industry where the needs that you are providing to your customers is growing on a daily basis. So, we talk about these accounts that are kind of born in the cloud, and Ample Organics is certainly one of them, and you're doing some amazing things with the resources behind AWS, so thank you. Congrats. All right. I'm going to spend just a few seconds here talking a little bit about AppStream. So this is the GPU version, and by the way, the reason I'm talking about this is we're giving away some GPUs here at the end of the session, which will be exciting for a few of you. So what is Amazon doing with AppStream 2.0? This is really kind of your secure VDI managed streaming services. We have seen a lot of areas where AppStream really can benefit customers, especially in areas of running applications in a browser, instant access to applications data, security. It was really good. Glenn kind of pointed out some of the things around a security standpoint. This is something that AMD takes very seriously. In our CPUs, we provide, as Glenn mentioned, we provide things where we designed our architecture to make sure we don't do prefetching that is susceptible to intrusion detection and sideband execution issues. And so we kind of take that same thing on the GPU side where, one of the feature sets that we are now starting to introduce into our GPUs is something called SRIOV, which is secure virtualization at the GPU level. And this is something where, especially if you're running VDI GPU environments, this is something that, to have that secure layer of containerization within the GPU, not just on the CPU, this is something different that AMD is actually doing in the marketplace. And so, as we see some of the use cases for AppStream on the GPU side, I will kind of give you a real-life case study. One of the major automotive manufacturers just had a major product announced just a few months ago, and that configurator was actually brought to life on AppStream 2.0. And so if you think about some of the, and by the way, they got massive accolades on the success of that configurator and how quickly it was brought up to really kind of give people a, what is a possibility for configurations for this particular auto manufacturer introducing kind of, the hottest product of this year. So, that's one of the use cases that we've seen. We've also seen use cases, anywhere from workstation experience to your desktop, all the way through scaling on demand. And so this is an area where AWS has brought AMD GPU technology. And so if you look at the instance types that are running on AMD GPUs today, stream graphics, design large, extra large, 2x and 4x, and the hourly pricing is actually pretty aggressive, right? So talks about the amount of vCPUs as well as the memory and GPU memory allocated by hourly pricing. And from a worldwide standpoint on regions, not as big as on the CPU side, but willing to grow. Right now, AppStream 2.0 is available in about 7 regions, and if there is need, we are told that AWS will expand those as needed. So I'm going to skip those questions now. And I'm just going to kind of summarize here since I've got about 5 minutes left. So, what does AMD offer? I think from what you've heard from Densify, from what you heard from Ample Organics, we're just trying to, we're really trying to deliver better value for your dollar. And really that's what it's all about. Us being in the competitive marketplace of being able to, offer choice to end users, and not only offer choice, but also offer performance and value and benefit. That's really kind of what we're out there to do. Application capability, right? It's not you're not doing a heavy lift and shift over to an ARM type architecture. This is an x86 migration. This is a very simple thing to do, and obviously available now. So, I want to say thank you. Thank you for everybody to join us. Thank you for everybody watching on video. And I think what I want to do now is I probably want to give away some GPUs. Is that right, Adam? Very good. All right.